Unable. Yes.
Good afternoon, students. Yesterday I have taken in number system a rational number. I described everything, properties of rational numbers, a brief revision of all that things which we have done yesterday. Um, Properties of rational numbers, operational properties of rational numbers, density property of rational numbers, all we discussed yesterday. Now today you can see the classification of real numbers. Real numbers is divided into two numbers. One is rational number, another is irrational number. Yesterday I have already defined about the rational numbers and its properties. Today I will take irrational number. Irrational number is defined as a non-repeating and non-terminating decimal numbers. In other words, you can say that a number which is not rational is an irrational number. Now you see, every number which is terminating and which is non-terminating and non-repeating. Decimal number is known as an irrational number. For example, 0.10100 and so on, root 2, root 3, root 5, pi, etc. All this are irrational numbers. Now, illustration. Now you come to illustration. Illustration. Representation of irrational number on number line. Representation of irrational number on number line. Locate draw a line which goes from minus infinity to plus infinity. Take O and A as 0 and 1. Draw a line AB equal to 1 unit to the number line perpendicular at A. Students, I am repeating this thing. Draw AB equal to 1 unit to the number line perpendicular at A, and your AB is 1 unit. This is, now join OB. Triangle OAB is right angle at A. By using Pythagoras theorem, Pythagoras theorem, OB is equal to under root OA square plus AB square. By using Pythagoras theorem, OB can be written as under root OA square plus AB square, and OB can be written as under root 1 plus 1, that is root 2. Now taking O as center and radius as OB, draw an arc which intersect the number line at P, and this point P will denote the irrational number under root 2 on the number line. Taking O as center and radius equal to OB equal to root 2, draw an arc which intersect the number line at P. The point P on the number line will represent the irrational number under root 2. The point P on the number line will represent the irrational number under root 2. I am repeating the whole things once again. In order to locate the irrational number under root 2 on the number line, first of all you draw a number line which is taken from minus infinity to infinity. All the numbers lies on that. You may familiar with this. And I have taken 0 and 1 as O and A on the number line, and a line AB which is perpendicular to the number line at A, and in triangle OAB, by using Pythagoras theorem, we can find the length of OB. Length of OB I have shown you, that is under root 2, and after that taking O as the center and radius equal to OB equal to under root 2. Draw an arc which intersect the number line at P. Now this P will represent the irrational number on the number line. Now I am taking another example. Second example. Locate an irrational number under root 3 on the number line. First of all, you draw a number line in the same way as you did in previous example. Mark 0 as O and A as 1, and again you draw a line AB equal to 1 unit. Your AB equal to 1 unit, which is perpendicular to the number line at A, join OB. Similarly, draw BC equal to 1 unit to OB perpendicular at B. Now I am showing this just to see it. This point is C, join OC. Now taking O as center and radius equal to OC, how will find OC? In right angle triangle, OAB, right angle at A, OB is equal to under root OA square plus AB square. This is by Pythagoras theorem. This is by Pythagoras theorem, and we get OB is equal to under root 1 plus 1, that is root 2. Now again in right angle triangle, OBC, right angle at B, by using Pythagoras theorem you can write OC equal to under root OB square plus BC square, that is equal to under root 2 plus 1, it is under root 3. Now radius equal to OC equal to under root 3. After making the calculation of all such things by calculating the length of OC, after that your work is take O as center and radius equal to OC, draw an arc which intersect the number line at P, and this point P will represent the irrational number under root 3. And radius equal to OC equal to under root 3, draw an arc which intersect the number line at P. Therefore, the point P on the number line will represent an irrational number root 3. That's all about today's lecture, and we all learned about the irrational number and how to locate the irrational number on number line. After that, we are having the assignment session. I am putting some assignment to you. You can try yourself. Number 1. Locate an irrational number under root 5 on the number line Second, locate an irrational number under root 17 on the number line. Thank you. Vipul, is that it?